The last video we focused on acids and bases and identifying what makes something a strong acid. Now we're going to go on further and look at bases specifically. So we said the properties of acids were things like they had a pH below 7, acids contain hydrogen, they have exothermic reactions when diluted with water, they taste sour if they're safe to taste, and they are corrosive. Then we went through a list of strong acids, which you need to memorize. And then we spoke about the properties of a strong acid is that it ionizes completely in water, meaning it breaks up completely in water. Then we spoke about a weak acid and the fact that it does not ionize completely, it ionizes partially in water, and it gives a very low concentration of hydronium ions. Then we moved on to bases and said that bases feel soapy. You'll actually see that your soaps contain sodium hydroxide if you look at the back of the ingredients, and that's what makes it feel soapy, and the pH is above 7. And then we need to look a little bit further and look at some strong acids and bases, which we did. So our strong bases, if we look at our list, are, if you struggle to remember them, they're actually quite easy. They're generally your group 1 and group 2 hydroxides on your periodic table. So on your periodic table, if you look at your group 1s, things like lithium hydroxide, sodium hydroxide, potassium hydroxide, even though they might not be on this list that we made, those are your strong bases. Then if you look at your group 2, things like magnesium hydroxide, calcium hydroxide, those are your strong bases. So group 1 and 2, remember group 1 and 2 are called alkali and alkali earth metals, and there's a reason for that. Alkalis are bases that you dissolved in water. So group 1 and 2 form strong bases when they are hydroxides. So all of these are group 1 and 2 hydroxides. Then we made a little list of some common weak bases that you need to know. We said sodium hydrogen carbonate, sodium carbonate, calcium carbonate, and ammonia. Ammonia is that ingredient that is in Handy Andy and in cleaning products. Okay, then we need to go a little bit further and go on to what is a strong base and a weak base, like we did with acids. So starting with strong bases. Okay, so for a strong base, we're actually going to start with one of the ones we just mentioned. We're going to go with sodium hydroxide. Okay, and we are going to write down, well, first of all, we need to write down what's the definition of a strong base. So take a moment and write down this definition, which is here. A strong base in the top right-hand corner says strong base is something that dissociates completely in water to give a high hydroxide concentration. So strong bases dissociate. You'll notice that we said strong acids ionize completely in water. Now, essentially, these things are the same. Dissociate means when you break apart. So if you dissociate from someone, you distance yourself from someone. So dissociate means to break apart. You just use different terminologies with acids and with bases. So acids ionize, bases dissociate. So a strong base dissociates completely in water and gives a high hydroxide concentration, and a weak base dissociates partially in water to give a low hydroxide concentration. But let's just stick with strong base for now. So you'll need to write this definition down. A strong base dissociates completely in water to give a high hydroxide concentration. Now, to explain that, we really need to write an example down and draw a little picture for ourselves. So we've chosen a strong base, we've chosen sodium hydroxide. Now we're going to add it to water and we are going to see what forms. Now, when acids broke up, remember that they always formed hydrogens, and those hydrogens immediately bonded with the water and it formed hydronium. Bases are a little bit different. So bases break up. So in this case, it's going to break up into sodium, which is +1, and hydroxide, which is -1. So that's what we're going to write. Sodium +1, hydroxide, which is -1, and water. Now, unlike acids, when acids break up, remember like something like HCl in comparison, would have broken up and formed H+, Cl-, and water. But when acids break up, that hydrogen bonds with the water and forms hydronium ions. When bases break up, something like that does not occur. These two things don't bond and give you something different. Okay, so we don't look at it the same as we look at acids. Now, when you do bases, the rule in chemistry is when you write an equation and there's something written on the left and on the right and it's the same, you should cancel it out. Okay, so if there's water on the left and on the right, we should cancel them both out, which means when I rewrite this, it's going to look quite strange. So I'm going to write sodium hydroxide, arrow becomes sodium plus and hydroxide minus. So because the water is not really involved, and that's a weird thing to say, the water is obviously important, it needs the water to dissociate or to break up, but the water is on both sides and it doesn't really combine with anything and form a different product. So we can leave the water out. If you want, you can write AQ here, and remember what all these things mean. S means something is in solid phase, L means something is in liquid phase, and these sort of things are going to become more and more important as we go on with chemistry. So solid, liquid, we have gas phase, and then AQ means aqueous, which means it's been dissolved in water. Okay, so if I look at this, if I write aqueous here, it means that I've dissolved my sodium hydroxide in water. So it's not really necessary then to worry about the water. I've already said that it's broken up. Now, if I look at this and I break up my sodium hydroxide, and I draw a little picture of this, which is always very useful when it comes to the definition of strong and weak acids and bases. Sodium hydroxide is a strong base, which means it dissociates or breaks up completely in water and gives a very high hydroxide concentration. Now, the last time we said if you don't feel like writing out the word concentration, you can write the substance in square brackets, and that means concentration. So when I write high square brackets OH, what this means is it's a high concentration of hydroxide ions. Now, what does that mean? It means when you look at a beaker of sodium hydroxide that's then dissolved in water, what you'll see is a lot of Na plus ones and a lot of OH minus ones, but you will not see any NaOH molecules. NaOH wants to break up and form ions. It wants to dissociate is the word you use with bases. So it will break up completely and it will form a lot of sodium ions and a lot of hydroxide ions. That's what strong bases want to do. Now we spoke last time about arrows and that most reactions are reversible, so they have a double arrow. And in this case, because this base is very strong and it wants to break up, we can actually just draw one forward arrow like that. If we draw a reverse arrow, we are saying that the sodium will rejoin with the hydroxide and become sodium hydroxide again, and it won't. The sodium hydroxide wants to break up, and when it's broken up, it wants to stay broken up. So this sodium hydroxide will break up and stay broken up, and therefore I will just do a one forward arrow like that. Then moving on to your heading is weak bases. So we need to just write the definition of a weak base first. Okay, so a weak base in the top right-hand corner again of your table. This is not in your notes, so you'll need to write this down. Weak bases dissociate partially in water to give a low hydroxide concentration. So you can write that down. Okay, so they dissociate partially in water to give a low hydroxide concentration. Then let's go on and do an example of that. So a weak base, remember we made a little list of weak bases. It was like sodium hydrogen carbonate, calcium carbonate, and ammonia. And the one I'm going to use is ammonia because there's actually something that's a little bit different about this one. Now remember we said that bases are things that break up and form hydroxide ions, okay? And acids are things that break up and form hydrogens, and we know that those hydrogens then bond with water and form hydroniums. So what makes something an acid is that it has hydroniums, and then what makes something a base is that it has hydroxides when it breaks up. Now you can clearly see from this one, ammonia doesn't have hydroxide in it. Okay, ammonia, unlike sodium hydroxide, doesn't actually have hydroxide in it. So how on earth are you actually going to form hydroxide? So I'm going to start with drawing the arrows like this, and then I'll correct it afterwards. So the only way that this can happen is if your ammonia, when it dissolves in the water, how can this water transform into hydroxide? So at the moment, it's got two hydrogens and an oxygen. The only way it can turn into OH is if it gives away one of its hydrogens, and it does exactly that. It gives away one of its hydrogens to ammonia, and it actually becomes ammonium. Remember the compound ion ammonium, and then it becomes hydroxide. Now you can see that ammonia didn't have any hydroxide in it, yet it manages to form hydroxide when it dissolves in the water. Now, previously we said if something was on both sides of the equation, we cancelled it out. However, you can see in this case, it actually hasn't happened. I'm actually not going to cancel out my water because it's not on both sides of the equation. My water is on the left, but then it's turned into hydroxides on the right. So when you do these ones that are like weak bases, and there is no hydroxide in the actual base, the only way it's going to form hydroxide is when it reacts, or when it dissolves rather, in the water, and it forms hydroxide. It gives away one of its H's and it forms hydroxide. Now let's go back to the definition. Let's draw a little picture of this again. So weak bases are things that dissociate, remember is the correct word, not ionize like in acids, that dissociate completely in water and give a very low concentration of hydroxides. Now what does that mean? It means if I could actually see the particles when I dissolve the space in water, I would see a lot of NH4 pluses and a lot of OH minuses, but I wouldn't see a lot of NH3 molecules. Well, I wouldn't see any actually. Okay, but actually no, I've actually made a mistake here. So if you look at this, I've just done the opposite of what I should do. So if you look at this, I should actually, if it's a weak base, it should not break up. So sorry about that. Let's erase that. Weak bases do not break up completely. So what I'll actually see is I will see a lot of NH3. I just treated this as if it was a strong base, and it's actually not. So I will see a lot of NH3s and a lot of water, but I will not see any NH4, or I'll see very few. I shouldn't say a lot because the definition says it dissociates partially. So I'll see very few of these, but I'll see a lot of NH3. Why? Weak bases, unlike strong bases, do not want to break up. Okay, and even if they do break up, so let's say we draw these arrows. Okay, let's draw them like this first. Even if they do break up, they will then want to rejoin back together and form ammonia again. So in terms of arrow length, if we were drawing this accurately, we should have a short little forward arrow and a long reverse arrow, meaning that the forward reaction does not really want to happen. The ammonia doesn't really want to break up and form ammonium and hydroxide. It wants to stay as ammonia, and even if it does break up, that broken up particles then want to rejoin and form ammonia again. So that's what weak bases do. Okay, they do not want to break up completely, unlike strong bases. Okay, take a minute and write that down, then we'll move on to the next thing. The next thing we move on to is a little bit more theory. So there were two scientists, as you saw from the live worksheets, that came up with different theories, or two sets of scientists rather, that came up with different theories of what acids and bases are. So the first one you can write down, let's highlight this one here, is Arrhenius's theory. Okay, so you can write as a heading Arrhenius's theory, and then you can write down this definition and this definition. So Arrhenius said that an acid is a substance that ionizes in water to produce hydrogen ions. Now, from what we've done already, we've already kind of know this, okay? Then bases are substances that dissociate in water and produce hydroxide ions. Now, again, like I said, we pretty much already know this, but you do need to know that Arrhenius said this, and if they ask you what is Arrhenius's definition of an acid, you will basically give this exact definition. And if they ask you what Arrhenius's definition of a base is, you would give this exact definition. Okay, so acids are things that ionize in water and produce hydrogen ions, which we know becomes hydronium ions, and bases are things that break up or dissociate in water and form hydroxide ions. So take a second and write that down.